Check one. Check one. Check one. Right. Hello, everybody. Back again with our heat changes associated with chemical reaction lesson, day 2. Already we finished day 1 session. Today is day 2 session, which means we have a set of homework questions to discuss and a small experiment to discuss. That's it we have for today. So with that, your heat changes associated with chemical reaction, that is your unit number 8 will be done. Okay. Okay, before we start, confirm me from your end, is the video, audio, everything clear? Yes, perfect. Right. Hari Henang, without any time wastage, we'll start the session. We were doing about heat changes associated with chemical reaction, and under that we were solving questions. How do we solve the question in heat changes associated with chemical reaction? Now, they might ask you to calculate the heat value. Heat is symbolized as Q. Heat change that occurred during a chemical reaction. That is Q. Q is equal to total mass of the substance multiplied by specific heat capacity of that solution multiplied by, what is this? Theta. Theta is temperature change. So Q equals MC theta. Sometimes temperature change, theta won't be given. If they don't give the theta, guaranteed they will give you the final temperature and initial temperature value. So if you have final and initial temperature, you subtract those two, you can find the theta, temperature change. So using that, we solved 5 questions. Yeah. First one done, second one done, third done, fourth done, fifth one. Did I finish the 5th question last week? Can anybody tell me? I finished 5th question in the class? Yes, done. 5th one also done. Which means your homework is 6, 7, 8, 9, 10. 6, 7, 8, 9, 10. Hurry. Take the homework. Question number 6. Don't just sit here and wait. You have not come to watch a movie here. You have to work. In case if you have not done your homework due to a valid reason, then see that at least before me, try to finish it. Don't try to create any reasons. You are in your grade 11, you're at your 16 years, grade 11. going to go for a public exam, don't try to create any reasons. If you are really at a situation where you couldn't do the exam, at least do before me, right? Question 6. A reaction was initiated on a solution with initial temperature 33 degrees Celsius, Ti is given, with a mass of 500 grams. If the final maximum temperature reached was 39 degrees Celsius, my initial 33, final 39. Initial 33, final 39. Initial temperature 33 degrees Celsius. Final temperature 39 degrees Celsius. Ehenang, tell me what's the theta value? What's the temperature change? Theta is final minus initial temperature. Final 39 degrees Celsius. Initial 33 degrees Celsius. Then your theta value is 6 degrees Celsius. Theta is 6. They are not asking that. Mass is given 500 grams. I'll write that also. Be careful. They have given it in grams. You have to convert it into kilograms. What else is given? Calculate the heat change. Specific heat capacity of the solution is 350. Specific heat capacity. Simple C is 350 joules per kilogram per degree Celsius. Lamayo. M is given. C is given. Theta is given. Can't you find the Q? We'll work it out now. You apply the equation Q equals to MC theta. M value is given 500 grams. Can I write it in grams? No. I have to convert it into the SI unit of mass. SI unit of mass is kilograms. Oh, now do in the mind itself. 500 grams. How many kilograms? 500 grams. Half a kilogram. Half a kilogram. 500 grams is half kilograms multiplied by C. Specific heat capacity is 350 joules per kilogram per degree Celsius multiplied by temperature change. Theta value is 6 degrees Celsius. Now do the math. Half of 6 is 3. Half of 6 is 3. 3 into 350. So 100, 1050. 1050. Half into 6, 3. 3 into 350. 3 into 350. 1050. Check with the units. Kilograms per kilogram cancel off. Degrees Celsius per degree Celsius cancel off. So your answer comes in joules. Raise hand those who got this. Right. Very good. Others, quickly copy it. I can give a long time. Quickly copy it. I hope others did it, but maybe a calculation error is there. If so, quickly copy it. If you are not done, then you are at a problem. 1 week is given for just 5 questions. Right. Next question. Question 7. Hydrochloric acid of mass 50 gram was reacted with 50 grams of sodium hydroxide. Hydrochloric acid 50 gram reacted with 50 gram sodium hydroxide. 50-50. Hydrochloric acid 50, sodium hydroxide 50. Hydrochloric acid 50, sodium hydroxide 50. Ehenang tell me lamai M. M is total mass. Total mass is how much? Hydrochloric acid 50 gram, sodium hydroxide 50 gram kiyanne. Total mass is how much? 100 grams. So you do the question for total mass, not for the hydrochloric acid mass or sodium hydroxide mass. You do the question for the total mass, 100 grams. The heat change occurred was, now the heat change is given 2100 degrees, 2100 joules. Heat change is given, Q value is given 2100 joules, right? And the initial temperature was, initial temperature, Ti is also given 25 degrees Celsius. Ti is given 25 degrees Celsius. Calculate the final maximum temperature during the reaction. Now the question is asking the final maximum temperature. How much is the final? Good question. Specific heat capacity of water is 4200 joules per kilogram per degree Celsius. Specific heat capacity is given 4200 joules per kilogram per degree Celsius. Now first look at the question. M is given, Q is also given, C is given, Ti is given, Tf is asked. How to solve the question? See, guaranteed the equation that we are going to use is Q equal mc theta. No doubt in that. Q value is given. M value is also given. C value is also given. But is missing theta. One value is not there. Theta is missing there. Now from this equation, I can find theta. Q is there, M is there, C is there, theta is missing, means theta I can find. If I know theta, can't I find the Tf value? If I know theta, can't I find the Tf value? Ti is also given. Can't I find the Tf value? So first this map should come into your mind. Q equals mc theta, Q is given, M is given, C is given, theta missing. So my first priority is I need to find the theta. If I know theta, I can find Tf. That's the map we are going to use. Some people, instead of theta, they directly write Tf minus Ti. If you're good at maths, directly you can write Tf minus Ti and solve the question. Same process, right? In one step you can do. Here what I'm doing is I'm first finding the theta, then I'm finding Tf. Hurry, we'll do the question. If I apply the values, Q is equal to mc theta. Q is given now 2100 joules equal. M is given in grams, 100 grams. How to convert grams to kilograms? How to convert grams to kilograms? You divide by 1000. 100 grams. How to convert to kilograms? You divide by 1000 kilograms. C value is also given 4200 joules per kilogram per degree Celsius. Theta value is missing. I'm going to find the theta. On. Now maths. Those who didn't do, work with me. I can give separate long time for you. So work with me. First, the zeros we can check and cancel off. Neither. Zeros I can check and cancel off. 1, 2, 3, 0 in the denominator. I'm cancelling it with 1, 2, 3 zeros in the numerator. 3 zeros denominator, 2 zeros, 1 0, 3 zeros numerator, cancel off. Look at this side. Here 1 0, here 1 0, I can cancel. Neither. See how I cancelled off. These 3 0, top 3 zeros cancel. Here 1 0, here 1 0 cancel, which means this full part is cancelled off. Here I have 42. Can't cancel me. Why, Puta? Why you can't? See, 2, 2100 equal 100 over 1000 multiplied by 4200. See, 230, 1230 cancel off. Now, equation either side parts you can cancel off. That you can do. No? This side you can cancel off. Left hand side, right hand side, same values you can cancel off. Multiply by 10, multiply by 10, cancel off. So multiply by 10, 10, multiplied by 10, 10, cancel off. So that's how I cancelled off. Hurry. So those zeros got cancelled off. So basically this full part is gone. What is remaining here? Only 42. I take 42 to the other side. Multiplication on other side become division. 42 I take to the other side. Multiplication on other side become division. So here I will have only theta. Theta is equal to 210 divided by 42, which gives us 5. 40 into 5, 200, 2 into 5, 10. Yes, 5. 5 degrees Celsius is your theta value. That's not your final answer. That's your theta value. They are not asking theta. They are not asking temperature change. What are they asking? What are they asking? They are asking the final temperature. Temperature change. Now we found initial temperature 25. They are asking TF. Now apply your second equation. Second equation. Theta equal final minus initial temperature. Theta we found out 5 degrees Celsius. Final temperature we don't know. That is what they are asking. Initial temperature is given 25 degrees Celsius. Minus 25, take it on other side, plus 25. Which means TF is equal to plus 25 plus 5. 25 plus 5 is 30. 30 degrees Celsius. Raise the hand those who got this. Raise the hand those who got it. Say specific. That's a good question. Say specific heat capacity constant, because most of the time it is 4200. No, it's not constant. Depending on each and every substance, specific heat capacity will change. Water 4200. If they talk about some other substance, it is some other value. Mostly reactions you have a lot of water, so we consider water and do the question. But always it's not water. Depending on the substance, specific heat capacity will change. Yeah. Those are writing quickly, write and fish. This part is fully maths and cancelling zeros is fully maths. Yeah, sixth question 350. Yeah, there you go. Sixth question 350 joules per kilogram per degree Celsius was the specific heat capacity, which means it depends on the substance. Harined. That's a good question, Savantan. Those are got wrong. See that you all again try it and don't just look at mine and copy it. Again try it. Eighth question. On question and question. This is question. Send me your answers for the eighth question first before I start the question. Just send your answers and keep. Sorry. Right. All of you are correct. Huh? I didn't get a single wrong answer. All those who are sending are correct. Hurry. Perfect. Good. I'll solve the question. See, it's a bit different. Where you need to think on 40 centimeter cube of dilute sulfuric acid was reacted with 60 centimeter cube of potassium hydroxide solution in a closed vessel. 40 centimeter cube sulfuric, 60 centimeter cube potassium hydroxide. Centimeter cube is for volume. They have given the volume of sulfuric, volume of potassium hydroxide. Question 8. Volumes are given. Volume of sulfuric is given 40 cubic centimeter. Volume of potassium hydroxide is given 60 cubic centimeter. Onna puta, volumes are given. Volume of sulfuric is there, volume of potassium hydroxide is there, both are reacted. Now, both are reacted means first tell me the total volume there. Sulfuric 40 centimeter cube, potassium hydroxide 60 centimeter cube, both are reacted together. Then what's the total volume? 100. So I have the total volume. Total volume is there 100 centimeter cube, right? They are talking about volume. Initial temperature of both solution is 27 and the final maximum temperature is 31. Initial temperature 27. Final maximum temperature 31. Onne one shot tell me what's the theta value? 27, 31, yeah, 4. 4 degrees Celsius, right? Theta is given. Calculate the heat change, Q value they are asking. Density of water, Q value they are asking. Additionally, they have told density of water. From nowhere, density is coming. Density of water is 1 gram per cubic centimeter. Density of water 1 gram per cubic centimeter. Specific heat capacity 4200. Specific heat capacity joules per kilogram per degree Celsius. First see what is given, what is not given. They are asking Q. Then guaranteed my equation is Q equals MC theta. Now see what is given, what is not given. They are asking Q. Have they given specific heat capacity? Yes. Have they given the theta value? Not directly, indirectly, however, theta we know. But have they given the mass directly? In the question, are they telling anything about the total mass of the solution? No. Mass story is not there. But instead of mass, some other details are given. Density is given, volume is given. Those are additional details. Density given, volume given, mass not given. Now you think, now you map, now you create a map in your mind. Density given, volume given, mass not given. Ehinang tell me, using density, volume and using density and volume, can I find the mass? Using density and volume, can I find the mass? Is there a relationship between density, volume and mass? Is there a relationship between density, volume and mass? Yes. What's the relationship? What's the relationship? Density equal mass divided by volume. Not grade 11, not grade 10, grade 9. In grade 9, you learned this equation. Density equal mass over volume. Onna puta, density is given, volume is given. Can't you find the mass? If you know the mass there, can't you find the Q value? That's the map. When you read the question, that map should come into your mind. D given, V given, M we can find. From there, M, C, theta, Q we can find. So my first job is I need to find the M value. We'll find it. Understood the method? Those who didn't do or couldn't do? Understood the method now? How to find the mass? Yes. D is given, V is given, M I have to find. If I need to find M, I have to subject M. If I subject M, volume goes to the other side. Division on the other side become multiplication. Division on the other side become multiplication. Then M is equal to D into V. M is equal to dV. I have to go to the other side. D is given. D is 1 gram per cubic centimeter. V is given. Total V you have to write 100 cubic centimeter. Only if you write the total V, you will get the total mass. So total V you write. So from there, I have the mass value. Mass is 100 into 1 is 100. Centimeter cube per centimeter you cancel off. I get the answer in grams. 100 grams. Be careful. Mass is there in grams. So now I know the mass. Next job, I need to find the Q value. Next job, I have to find the Q value. How to find the Q value? Q is equal to MC theta. M value 100 grams. Write it in kilograms. 100 divided by 1000 kilograms. C value is given 4200 joules per kilogram per degree Celsius. Theta, temperature change we found 4 degrees Celsius. Now maths. Q is equal to 1230 1230 cancel off. 420 multiplied by 4. 420 multiplied by 4. 400 multiplied by 4, 1600. 20 multiplied by 4, 80. 1680 joules. All those who send me the answer, you are correct. I got this answer from all of you. Those who didn't do, again see, volumes are given, theta value we found, C is given, D is given. Which means we can't directly apply Q equals MC theta. To apply Q equals MC theta, we should know the mass. First we found the mass. How? Density equals mass over volume. To subject mass, V goes to the other side. Division on the other side become multiplication. Then M is equal to dV. D is 1 gram per cubic centimeter. V is 100 centimeter cube. You cancel off, you get 100 grams. So mass is 100 grams. Now you apply it for Q equals MC theta. M is 100 over 1000 kilograms. C is 4200. Theta is 4 degrees Celsius. You multiply, you get 1680. Maths part you can do instead of cancelling these zeros, another zero, you can do. That's no problem. Those are maths, no? Finally, you should get the same answer. Hurry, right. Come to question 9. Acid and a base solution of equal volumes on key point. Acid and base. Acid is there, base is there, of equal volumes. Of equal volume means if this is 100 cubic centimeter, this is also 100 cubic centimeter. If this is 500 cubic centimeter, this is also 500 cubic centimeter. Acid and base of equal volumes, 100 centimeter cube each. Underline or highlight the word each. Acid and base of equal volume, 100 centimeter cube each. What does that mean? Acid 100 centimeter cube, base 100 centimeter cube. That's the meaning. You have acid 100 centimeter cube volume, base 100 centimeter cube volume. Ehenang tell me what's the total volume there? What's the total volume? 200. 200 cubic centimeter. Were reacted and the temperature rised from 90 to 110. One shot tell me the theta. 90 to 110. One shot tell me the theta value. 20. 90 to 110. Difference is 20. So directly I write the theta value. Theta value is 20 degrees Celsius. Right. Calculate the heat released, Q value. Density of water is given 1 gram per cubic centimeter. Heat capacity is given 4200. Calculate the heat released. Specific heat capacity 4200 joules per kilogram per degree Celsius. And density of water is given 1 gram per cubic centimeter. If I apply Q equals mc theta, C value is given, theta value is given. Is the M value given? Is M value given? No. So guaranteed I should use V and D, find the M. Same like the previous question now. Using V and D, I find M. Then I apply here, do the question. Right. Density equals mass divided by volume. I subject mass. Mass is equal to density times volume. Density is 1 gram per cubic centimeter multiplied by volume is 200 cubic centimeter. If I multiply 1 into 200 is 200 centimeter cube per centimeter cube cancel off. You have grams. So you get your answer in grams. 200 grams. That's not the final answer. That's just the mass. Now you applied this side. Q equals mc theta. Q is equal to 200 grams. Write it in kilograms. 200 divided by 1000 kilograms multiplied by specific heat capacity 4200 joules per kilogram per degree Celsius. Theta value 20 degrees Celsius. Now do the math there. Q is equal to 1230. 1230 cancel off. 2 into 2, 4. 4 into 4, 420, we already know 1680. Another 0 is there. Another 0 is there. 1680. Another 0 is there. 16,800 joules. Those who got this answer? Got. Got. Good. Okay, no? Come to the last question. Last question. Hydrochloric acid of volume 300 cubic centimeter was reacted with dilute sulfuric acid of volume 200 cubic centimeter. 300 reacted with 200. 300 reacted with 200. 10th question. Volume of hydrochloric acid and volume of sodium hydroxide. 300 cubic centimeter, 200 cubic centimeter, right? So hydrochloric acid is reacted with a base. Question is, what type of reaction occurs between acid and base? What type of reaction occurs? Most of you will tell neutralization. From acid bases knowledge, between acid and a base, neutralization occurs. But only if you write it, you are not 100% correct. Neutralization, hurry, acid base reaction is neutralization. Tell me, depending on heat change, acid base is exothermic, the endothermic. Exo, endo. Heat is released, heat is absorbed. Exo. And that is why look at all these questions. In all these questions, see, acid and a base solution of equal level were reacted and the temperature is this. Calculate the heat released. Calculate the heat released. I am asking the heat released. Previous question, dilute sulfuric acid, potassium hydroxide solution, initial temperature, this, blah, blah, final temperature. Calculate the heat. Here, heat change is given. Heat change can be released to absorbed. However, it's about released. So all this question I'm talking about heat released. Heat released. So heat released. Even this question, somewhere here. Calculate the amount of heat released. Heat released. Heat released means endo-exo. Endo-exo. Exo. I never gave the word absorbed. If I give the word absorbs, you can argue. No. Heat released. Heat released means is exo. So from acid bases knowledge, you know, acid base reaction is neutralization. From this, you know, it is exothermic. Then both together you write it as exothermic neutralization. This is a exothermic neutralization. Write both. Write both and keep exothermic neutralization. Roman 2. What is the total volume of the solution? Anelamai Baba question. Volume of HCl is 300. Volume of sodium hydroxide is 200. Then total volume is going to be 300 plus 200, 500. 500 cubic centimeter. C question. Calculate the total mass of the solution. Density of water is 1 gram per cubic centimeter. Calculate the total mass of the solution. Density of water is given 1 gram per cubic centimeter. That's your C question. Density is 1 gram per cubic centimeter. They are asking the mass. How to find the mass? Now you know the logic. Volume is given. Density is given. How to find the mass? Use the equation. Density equal mass over volume. Subject mass. Mass is equal to dV. D is given 1 gram per cubic centimeter. Multiplied by total volume is 500 cubic centimeter. So if I multiply, I get the total mass as 500 grams. Total mass is 500 grams. These questions work with me itself. A done, B done, C done. D part. If the initial temperature was 45 and the final maximum is 47, one should tell me the theta then. Initial 45, final maximum 47. What's the theta? 2 degrees Celsius. Theta is 2 degrees Celsius. Calculate the amount of heat released. Q they are asking. Specific heat capacity of water is 4200. Specific heat capacity 4200 joules per kilogram per degree Celsius. And mass I already calculated 500 grams. Now apply the equation. Q is equal to mc theta. M we already calculated 500 grams. 500 grams is half a kilograms. Multiplied by specific heat capacity is 4200 joules per kilogram per degree Celsius. Theta value is 2 degrees Celsius. So if I do the math there, half multiplied by 2, cancel off, no? Half and 2 will cancel off. Half into 2 is 1. Half, 2 cancel off. So what is remaining is 4200 joules. Raise the hand, those, right? Raise the hand, those who got it. Right, good. Others quickly write down. So if we only write exothermic, will we get the full marks? It's a MCQ question. What I gave here is a MCQ question. 2000, I can remember, recent year. Between acid base, what kind of reaction occurs? Endothermic neutralization, exothermic neutralization, just neutralization, just endothermic. They gave. I can't remember the correct one. That's how they gave. What's your answer? Exothermic neutralization. That's what I expected here. That's why I gave the answer here like this. It's a past paper MCQ question. Okay, no? Right. That's it. So now we all know all the calculations. All the calculations in heat changes associated with chemical reaction. All the calculation part is done, right? In case if you have got wrong in any of these questions, again sit and do the question separately. Take your own time and do it again. And however, the YouTube video will remain. If you are stuck somewhere, again you can rewatch the YouTube video as well. So see that all these questions, in case if you are stuck at any question, you're gone wrong or calculation, cutting the zeros, cutting half and two hammer, if there are any calculation errors, again one time redo it and see. Again one time redo it and see. Okay. Hurry. That's it. The calculation part is done. Next part of this lesson. Listen. Ne? So now you know during a chemical reaction, a heat change will take place. Either it can be heat absorbed, endothermic reaction, or it can be heat released, exothermic reaction. So during a chemical reaction, heat change will take place. And we mathematically found out how to calculate this heat change. Q equal mc theta. Mathematically, how to calculate. So theory wise, you know, there is a heat change happening. Calculation wise, you know how to calculate it. Now, practical wise, experimental wise, do you know how to calculate the heat change during a chemical reaction? Now let's take inside this water bottle, we'll assume this water bottle is a beaker. This is a beaker. If you are seeing something else, you are not a science student. This is a beaker. What are you saying now? Beaker. Very good. So this is a beaker. Inside this beaker, a chemical reaction is taking place. During that chemical reaction, practically, there will be heat released if it is exothermic or heat absorbed if it is endothermic. How do we practically find out the amount of heat change taking place? How to practically do it? How to practically find out the heat change during a chemical reaction? For that, we have a very important experiment. Only from this experiment, we can make a separate essay question. Such an experiment. Experiment, this is experiment. Whatever you learned in grade 10, those things are just activities. You can't even call them experiments. This is a superb experiment. How to calculate the heat change taking place practically during a chemical reaction. How to calculate the heat change taking place practically during a chemical reaction. Experiment. Now, what is the chemical reaction we are going to do? Neutralization. We are going to find out during neutralization is acid-base reaction. During acid-base reaction, how much is the heat change taking place? Practically, we are going to find out. Right. What you do? There you go. In a beaker, you take 50 centimeter cube of, 50 centimeter cube means that's the volume. 50 centimeter cube of 1 mole per decimeter cube of HCl solution. 50 centimeter cube, 1 mole per, 2 mole per decimeter cube of HCl solution. 50 centimeter cube, 2 mole per decimeter cube. 50 centimeter cube is the volume. What is 2 mole per decimeter cube? Now, for what quantity we use the unit mole per decimeter cube? What's the quantity represented here? Concentration. Concentration is given there. So, volume is 50 centimeter cube. Concentration, even the concentration is given. 2 mole per decimeter cube HCl solution into a beaker. Another beaker, there you go. Another beaker, you are going to take sodium hydroxide of volume 50 centimeter cube with concentration 2 mole per decimeter cube. So both HCl and sodium hydroxide 50 centimeter cube, 2 mole per decimeter cube are taken into two separate beakers. Then first you need to find out their initial temperatures. How to find the initial temperatures? You take a thermometer, put it inside. You can find the initial temperature of HCl. You can find the initial temperature of HCl. Just imagine initial temperature of HCl is 25 degrees Celsius. This for HCl. I put the thermometer, I take the reading. Initial temperature of HCl 25. Next what? I take the thermometer out. First you need to wash it. Now we are practically doing no. So I'll tell each and every step. So you take the thermometer, OA shape, you don't go to wipe it with your t-shirt. You take it and you wash it. Thoroughly you have to wash it. You wash it, put the thermometer into sodium hydroxide. Put the thermometer into sodium hydroxide. And take the initial temperature of sodium hydroxide as well. You write the initial temperature of sodium hydroxide as well. Just imagine initial temperature of sodium hydroxide is 27 degrees Celsius. Just imagine we are doing this experimentally. I got initial temperature of HCl as 25. Initial temperature of sodium hydroxide as 27 degrees Celsius. Right. Next what? Next, you have to take a polystyrene cup. Polystyrene cup කියන්නේ regiform cup. This is a polystyrene cup, regiform cup. Into this polystyrene cup, you put your HCl. And you put your sodium hydroxide as well. So inside this now I have HCl, sodium hydroxide, both are in aqueous state. Dissolved with water, aqueous state. Both are added. Guaranteed they are going to react. The moment you put HCl and sodium hydroxide into it, they will react. So just after you put it, what you do is, you put the lid, quickly you have to do these things. Oh yeah, you don't put these two and start talking to your friend all the gossips about that week. No, you can't do it that way. The moment you put it, next moment you close it with a lid, then you insert a thermometer and you put a glass rod inside. This is a glass rod. Why glass rod? Why polystyrene cup? Later I will tell. For now, just listen. You put a glass rod, you put a thermometer. Using the glass rod, you stir the solution. Continuously keep on stirring. While stirring, carefully look at the thermometer. Now tell me, what will happen to the reading in the thermometer? Reading in the thermometer will increase or it will decrease? HCl and sodium hydroxide are reacting. Now practically tell me, reading in the thermometer increases or decreases? It will guaranteed increase. Slowly, reading is going up. Reading is going up. Reading is going up, going up, going up, going up. You wait until you get the final maximum temperature. Final maximum temperature. There will be a maximum value that the thermometer shows. So until then, you wait here. Meanwhile, you have to stir it. You can't stop that. While stirring, you look at the thermometer until you get the final maximum temperature. Now let's just take, reading is going like this. 30 degrees Celsius, going to 31 degrees Celsius, 32 degrees Celsius, 33 degrees Celsius, 34 degrees Celsius, 35 degrees Celsius, 36 degrees Celsius, 35 degrees Celsius, 34 degrees Celsius. What's the final maximum temperature? What's the final maximum temperature? What is 34? Look at the readings. What's the final maximum temperature? 30, 31, 32, 33, 34, 35, 36. 35, 34. On 36 is the final maximum. That's the final maximum. After that, again, the temperature is reducing. So that's what I told you. Final maximum temperature is the temperature. Why not 34 is 34 maximum? There is a maximum here. 36. So temperature will increase, go to the maximum, it will come down. It will drop down. So it goes up, you take the final maximum, then it drops down. So practically when you are doing it, you don't know the final maximum. Practically, let's say you are doing this experiment. 30. You might think it is maximum. No, it goes to 31. You might now think it's the maximum. No, it goes to 32. You will think now it's maximum. No, 33. No, 34. No, 35. No, 36. Then it comes to 35. Then only you should know. It came to 35 means maximum was previous one. 36. Understood? When you are practically doing it, you don't know that it is the final maximum until it drops. You might think 30 is maximum. No. 31 is maximum. No. 36. Then it drops 35. Then you know the previous is the maximum. That's a practical scenario, right? Until the temperature falls to 35 here, you don't know this is maximum. So 36 is the maximum temperature. So now you know the final maximum temperature. See that you keep on stir it while you are doing the experiment. So now you know the final maximum temperature. How much? 36 degrees Celsius. Onna lamai. Initial temperatures are there. Final maximum temperature is there. Can't you find that? Can't you find the temperature change? Can. We can find the temperature change. That's the final maximum. We can find the temperature change. We'll find the temperature change. We'll find the temperature change. Tell me how to find the temperature change. How to find theta value? Theta is equal to final temperature minus initial temperature. Final temperature is 36 degrees Celsius minus. What is my initial temperature? HCl was 25 degrees Celsius. Sodium hydroxide is 27 degrees Celsius. What is my initial? What value am I going to write here? Is it HCl is 25 or sodium hydroxide is 27? What is my initial temperature I'm going to write? Think. Practically adding. Now, these are things that are going to happen practically. Add and write 54. 54, 52. Can 52 be the fine initial? Nah. 2 degrees. 2 degrees is the difference. No, I'm not writing the difference. I'm writing initial. What is my initial temperature? 25, the 27, the, or is it the average of these two? What am I going to write? Is it 25 degrees Celsius? Is it 27 degrees Celsius? Or is it the average? We have to write the average. So practically when you are doing it, you will come across these problems. HCl will have a certain temperature. Sodium hydroxide will have a different temperature. If so, you have to get the average and write. Because when the reaction starts, you mix them both, you get an average value. From there, only temperature increases. Tell me how to find the average. How to find the average initial temperature? Average Ti. How to find the average initial temperature? Initial temperature average. Average is equal to, you add these two, 25 degrees Celsius plus 27 degrees Celsius divided by 2. Addition divided by 2. How much? How much? 26. That's my average. So remember, if the temperatures are different initially, you get the average. Keep that in mind. Then you write the average. So average initial temperature is 26 degrees Celsius. If so, what is my theta value? How much is theta? 10. Theta is 10. So experimentally, I find out temperature change there is 10 degrees Celsius. This I am getting experimentally. Right. So experimentally, I know temperature change. Theta value 10 degrees Celsius. Then using a lab manual. Lab manual means in your lab there will be lab manual, a booklet. Using a lab manual, you find out the specific heat capacity of water. Now with the questions, tell me what's the specific heat capacity of water. So many questions we did know. You don't need to start searching a lab manual. You know. How much is the specific heat capacity? 4,200. So using a lab manual, you find out the specific heat capacity of water. 4,200 joules per kilogram per degree Celsius. And using a lab manual, you have to find the density of water. What's the density of water? That also we did with some questions. 1 gram per cubic centimeter. Density of water is 1 gram per cubic centimeter. These two you find using lab manual, or you go to Google and type what's the specific capacity of water, what's the density of water. So you find it using some other source. Theta value you find experimentally. Additionally, what else we have? Initially, I know 50 centimeter cube of HCl reacted with 50 centimeter cube of sodium hydroxide. 50-50 reacted. Ehenang, what's the total volume? What's the total volume? 100. So total volume also I know 100 centimeter cube. Using this, can't I find the Q value? Total volume I have, density I have, I can find the mass. M if I can find, C is there, theta is there, can't I find Q value? So if I do the question, my step one, I have to find the mass, density equal mass over volume. Mass is equal to density times volume. Mass is equal to density of water is 1 gram per cubic centimeter multiplied by volume is 100 cubic centimeter. From there, the mass is 100 grams. That's not the answer. That's just the mass. Next, I need to find the Q value. Q is equal to mc theta. mc theta. M 100 grams, I'll write it in kilograms. 100 grams in kilograms is 100 divided by 1000 kilograms. Using lab manual, I found out the specific heat capacity of water. 4200 joules per kilogram per degree Celsius. Experimentally, I found out the theta value, 10 degrees Celsius. If I do the math there, 1230 cancel off. 420 multiplied by 10. 420 multiplied by 10 is 4200 joules. So during this experiment, how much of joules of heat energy is released? 4200 joules. Experimentally, we found it. Experimentally, we did the experiment and we found the theta value. Using lab manual, we found specific heat capacity and density, and we found the mass. Mass we know, specific heat capacity we know, multiplied by experimental value for the temperature change, you get the Q value. Understood how to experimentally find out the heat change? Understood the procedures? So then why mole per decimeter cube is given? Later I will talk about it. This part understood? Why polystyrene cup? Those things I'll talk later. I'm talking about the calculation part. Sir forgot Supun. Ekane, Supun still didn't come. He will come. Hurry, right. Huh. Experimental determination of heat change during a chemical reaction. Neutralization. Things needed. 50 cubic centimeter, 2 mole per decimeter cube HCl, 50 centimeter cube, 2 mole per decimeter cube sodium hydroxide, 2 beakers of blah blah things are there. Method. Step 1. Measure the initial temperature of HCl and sodium hydroxide using thermometer. See, if initial temperatures are different, take the average initial temperature. Underline or highlight that. If initial temperatures are different, take the average of initial temperature. Step 2, mix HCl and sodium hydroxide into polystyrene cup and find the maximum final temperature using a thermometer while stirring with a glass rod. Setup is given to you. This is the setup. Using a lab manual, get the density of water and specific heat capacity of water. Assume that the temperature change is 10 degrees Celsius. Just think like we did the experiment and we found out theta is 10 degrees Celsius. Because we are going to do the question for 10. Maybe in the experiment you get 5. Maybe in the experiment you'll get 20. You'll get 30. Whatever the value you get, you put here. Here we assume that the temperature change is 10 degrees Celsius. Under that the box is given. In that box, write the calculation part. Write everything on this board. Now specific heat capacity and they are not given. Write those well, these and write this. Lab manual means there are manuals in the lab. In them you have these values. These values you don't need to memorize. In the question, in the exams, I'm giving it. I'm giving these values. And the lab, who is going to come and give you? Is the lab manual. Work. Okay, no? That should be draw anything. No, no, no. No need to draw. Okay, no? Right. So now you know how to experimentally find out the heat change. How to experimentally find out the heat change. Okay. Right. Listen, still experiment is not over. Hmm. The procedures are over. But still, some more things are there for us to learn. Now, during this experiment, Lamai, there are some precautions you have to take. There are some precautions. What are the precautions you have to take? Precaution number one, you are putting the thermometer into HCl solution. Then you are immersing it into sodium hydroxide. Then you are immersing it in the final solution. Before immersing into the next solution, you should wash it. It's a must for you to wash the thermometer before you immerse it into the next solution. Why? Why you need to wash it? Just imagine you put the thermometer into HCl. You put the thermometer into HCl. So around the thermometer, what will be remaining? HCl will be remaining. If you take that thermometer and directly immerse it into sodium hydroxide, if you take it and directly immerse it into sodium hydroxide, what will happen? On the thermometer, already HCl is there. It will start reacting with sodium hydroxide. So whatever the temperature you are going to get is for the reaction of HCl and sodium hydroxide temperature. Do we need the reaction temperature or we need only the sodium hydroxide temperature? We need only sodium hydroxide temperature. We don't want them to react here. Reaction is done separately. Reaction is done in a polystyrene cup, not here. So here, before you immerse it into sodium hydroxide, you should wash it. You should wash it and remove all the HCl there. Then only you immerse it there. Again, when you are putting it to the final solution also, it's a must for you to wash it. So precaution number one, you have to wash the thermometer. You have to wash it. Precaution number two, you can't use just a beaker to do this experiment. You should use a polystyrene cup. A regiform cup should be used. A regiform cup should be used. Why you use a regiform cup? Why can't you do it in a normal beaker? What's the reason? The reason is this. Now, if you do the experiment in a normal beaker, a part of the heat produced will be lost to the environment. A part of the heat produced during the reaction will be lost into the environment, which means there will be a heat loss. Tell me, if the heat goes to the environment, will the thermometer's temperature increase? If the produced heat goes to the environment, will the thermometer's temperature properly increase? No. Or exact 10 degrees Celsius of increment won't happen. Maybe the temperature will rise up to 8 degrees Celsius because the remaining 2 degrees Celsius, its heat amount is released out. So if there is a heat loss, the temperature in the thermometer won't rise properly. If the temperature doesn't rise properly, will I get an accurate value for the heat change? No. I can't get an accurate value. The value will be less. Why? There's a loss, no? So you all tell me, during the experiment, you should try to increase the heat loss or decrease the heat loss. You should decrease it. You should try maximum to decrease the heat loss, minimize the heat loss. That is why we are using a regiform cup. Tell me, in a regiform cup, can the heat go out? No. Heat loss is minimum. That is why our ice cream uncle is there, who comes in bicycle. He doesn't have a fridge, no? What he gives? What he gives? He gives a regiform box. right? Or ice cream uncle who comes with a nice horn or something like that. Yeah, the regiform box. Because in regiform box, heat loss is minimum. I won't tell heat loss is 100% stopped. No, heat loss is not 100% stopped. There will be a slight heat loss, but compared to a glass beaker, in a regiform cup, heat loss is minimum, less. Okay, and that is why, now think, that is why we put a lid as well. Think why we put a lid. If we don't put a lid, what will happen? Produced heat will go out. So we try maximum to lock the heat that is produced. So that's why we put a lid. And for stirring, why we use a glass rod? We can use a nice metallic spoon. In the kitchen, you all have spoon, silver spoon. You take a nice silver spoon, you put it and shake it. You can do it that way. But no, why we use a glass rod? Now think. Why not a metal spoon? Why a glass rod for stirring? Because if I put a metal spoon, through the metal, heat can go out. There will be a heat loss. What we do during the experiment, we try to increase the heat loss, so minimize the heat loss, minimize. If I put a metal spoon, heat will go out. We have to minimize it. We have to stop it. That's why we put a what? Glass rod. Glass. Tell me, glass can conduct the heat or it doesn't conduct heat? It doesn't conduct. It's a poor conductor. So we put a glass rod so that heat doesn't go out. So all these precautions are taken to minimize the heat loss. We use a polystyrene cup. We put a lid there. We put a glass rod. All those things are done to minimize the heat loss. Okay. So some of you will ask me, sir, so the rigiform cup, if you put the acid and the base, cup will melt. No. Neither. Neither. To a rigiform cup, you put HCl. It will melt. No. Then how is this practical possible? Now in your textbook, this is how the practical is given. But in reality, when we are doing the experiment, we don't do it like this. What we do is, yes, we take a regiform cup. Inside that we keep a brass cup. A cup made of brass. We keep a brass cup and in that cup only we do the experiment. So brass cup is there. It is surrounded by a regiform cup. Okay. So we do it in the brass cup. Not even in glass. Brass cup. It is surrounded by regiform cup. So however, around it you have the regiform cup. Around it to protect the heat, you have the regiform cup. That's how we practically do it. Okay, no? Huh. Precautions. Number one, you need to wash the thermometer before immersing in the solution. Number two, a regiform cup is used to minimize the amount of heat loss to the environment. Number three, a glass rod is used to stir the solution because it's a poor conductor of heat. Hence, heat loss is minimum. So these three are the precautions. Next, going to assumptions. Now, in this experiment, we make two assumptions. Experiment is done based on assumptions. That is how we do the experiment. And now, until now, already have learned one experiment in our grade O-level syllabus where you do assumption and do the experiment. That is under characteristics of life in grade 10. Under the experiment of proving that oxygen gas is inhaled during respiration. In that experiment, you do two assumptions. This is another experiment where you do the experiment based on assumption. Only these are the two experiments where you make assumptions and do the experiment in O-level syllabus. So this is an experiment where you make assumption and do the experiment. Under the assumption only experiment is done. First tell me, what is an assumption? Are the assumptions 100% true? Are the assumptions 100% true? No. It's not 100% true. So assumptions are not 100% true. Those are assumptions. Here also, in this experiment also, you make two assumptions. Are they going to be 100% true? No, they are not 100% true. But we make two assumptions and only do the experiment. Assumption number one. Assumption number one. We assume that there is no heat loss in the experiment. We assume that there is no heat loss, zero heat loss in the experiment, and only we do the calculation. This calculation is done assuming that there is no heat loss, zero heat loss. But tell me, practically when we are doing this experiment, can we 100% stop the heat loss fully? 100%. Can we stop the heat loss fully? Practically? No. We can't 100% stop it. It's impossible. Now you will tell answer, we are using regiform cup, we are using glass rod, we are using lid and all. Those are to minimize the heat loss. Even when I'm telling that, I told you. These things are used to minimize. But still, there might be some heat loss. Even though you use a polystyrene cup, even though you use a glass rod, even though you put a lid, there will be guaranteed a little amount of heat loss. Tell me, if there is a heat loss, can I do this calculation? Will this calculation come correctly? No. So before we do the calculation, we make an assumption. What's the assumption? There is no heat loss in the experiment. It's an assumption. Tell me, is it 100% true? No. It's not 100% true. It's just an assumption. So assumption number one, we assume that there is no heat loss and only do the experiment. But in reality, it's not 100% true. It's an assumption. Okay. Assumption number two. Assumption number two. Now what we are doing in the experiment? In the polystyrene cup, we are mixing up hydrochloric acid, sodium hydroxide solution, and measuring the temperature increment. We are mixing the solution and measuring the temperature increment. And we are applying Q equal mc theta and finding out the Q value. Right? So during the experiment, we have to multiply the specific heat capacity. We have to include the specific heat capacity value. And mass is not directly found. How we find the mass? Using density. Density equal mass over volume. From that only mass is found. Now tell me, in the experiment, density, whose density we are using to do the calculation? Whose density we are using in the calculation? Go to that box part. Read the first sentence before the box. First sentence before the box. Using a lab manual, get the density of water. Using what's density we are doing the calculation? Water's density. But y'all tell me, in the reaction, actually what is there? HCl and sodium hydroxide. In the reaction inside the polystyrene cup, what is there is HCl and sodium hydroxide. But the calculation is done for water. So can you see there is a contradicting point there? In the beaker, in the polystyrene cup, what we have is sodium hydroxide and HCl. Reactants are sodium hydroxide, HCl. But calculation is done for water. Density of water. There is a contradicting point there. So what we do there? Now we will tell answer, instead of water's density, write the density of the solution. How can we find the density of solution? It's practically hard. HCl and sodium hydroxide. Together, the solution will have a certain density. How do we practically find it? Practically it's a bit hard. Practically it's a bit hard to accurately find it. Therefore, what we do, we write the density of water. How can we write the density of water? See, Lamai, what do you mean by HCl aqueous solution? In a beaker of water, you put some droplet of HCl. That is HCl aqueous. What is sodium hydroxide aqueous solution? In a beaker of water, you put some granules. Sodium hydroxide comes as granules. You put some granules of sodium hydroxide, little bit of sodium hydroxide. That is sodium hydroxide aqueous. In lot of water, HCl is added, HCl solution. In lot of water, sodium hydroxide added, sodium hydroxide solution. Now tell me, so HCl aqueous solution, lot of water, little bit of HCl. Whose properties are more here? Is it water's property or HCl's property? In a beaker of water, you are adding some droplets of HCl. If so, whose properties are more influencing to the solution? Water's property. Then whose density will influence more to the solution? Water's density, not HCl's density. There will be a slight influence from HCl, but highest influence comes from water. Even look at sodium hydroxide aqueous. In lot of sodium hydroxide, in lot of water, a little bit of sodium hydroxide is added. Ehinang, whose property will influence the most for the solution? Water's property. Whose density will influence the most to the solution? Water's density. I don't tell sodium hydroxide density won't influence. There will be influence, but that influence is very small. So that means final solution's density will be mainly decided by whom? Final solution's density will be mainly decided by whom? Water. So which means we use the density of water to do the calculation. Density of water is well known, 1 gram per cubic centimeter. So we use the density of water to do the calculation. But you all tell me, in reality, will the solution's density be exactly equal to water's density? Will be exactly 1 gram per cubic centimeter? No. There is a little bit of HCl. There is a little bit of sodium hydroxide. Which means sodium hydroxide HCl's density also will contribute for the final solution's density. There will be a slight influence. So actually, if you are writing the density, you should write the solution's density, which is slightly above the water's density. But what we write water's density, 1 gram per cubic centimeter, not solution's density. So there is a contradiction there. Instead of solution's density, we write water's density. But we make an assumption there. There's a problem there, no? There's a contradiction there. No? To overcome that contradiction, we make an assumption. What's the assumption? Density of water is equal to the density of solution. That's the assumption. You all tell me, is it true? Can it be 100% true? Can the solution's density and water's density be 100% equal? No. Solution's density is slightly above the water's density because there's a little bit of HCl, little bit of sodium hydroxide. So solution's density will be slightly above the water's density. But we make an assumption that water's density and solution's densities are equal. Is it 100% true? No. It is an assumption. Okay. So the second assumption is we assume that water's density and solution's densities are equal. Water density and solution density are equal. Not only that, another assumption we make in the same calculation part. Tell me whose specific heat capacity we are writing there? Q equals mc theta, whose specific heat capacity? Specific heat capacity of water. We are writing the specific heat capacity of water. But actually, reaction is happening where? In the solution. So there also, can you see there is a contradiction? We are finding the heat change in the solution, but we are writing the specific heat capacity of water. Solution, we are writing the equation. Water, we are writing the specific heat capacity. Again, there's a problem. How we overcome the problem? We make an assumption. What's the assumption? Specific heat capacity of water is equal to the specific heat capacity of solution. Tell me, can it be 100% equal? Can be 100% equal? No. There's a little bit of HCl there. There's a little bit of sodium hydroxide there. The specific heat capacity won't be exactly 100% equal to water specific heat capacity. There is a slight difference, but we make an assumption that those two specific heat capacities are equal. Okay. So what is my second assumption? We assume that density of water is equal to the density of solution, and specific heat capacity of water is equal to the specific heat capacity of solution. Is it 100% true? No, it's assumption. So what are the two assumptions we make during this experiment? Assumption number one, no heat loss to the environment, which is a lie. Number two, specific heat capacity and density of the solution is equal to the water. Is it 100% true? No, it's assumption. So based on assumption only, we do the experiment. We create our environment for the assumption, for the experiment. Our experiment is for the solution, but we make assumption for the water and we do it. Okay. Second, one more time, what are the assumptions we make? No heat loss to the surrounding, assumption number one. Assumption number two, density of the solution and specific heat capacity of the solution are equal to the density of the water and specific heat capacity of the water. Those are two assumptions we make. Assumption. We assume that there is no heat loss to the environment during the reaction. Number two, we assume that density and specific heat capacity of solution is equal to the density and specific heat capacity of water. There's a question. Why should the solution be continuously stirred? Why we should stir the solution? During the experiment, I told you continuously you have to keep on stirring. Why? To mix? Why we should mix? Why we should mix? See, if I don't stir it, maybe there will be a lot of HCl and sodium hydroxide at the top, maybe. Lot. And a little bit of HCl and little bit of sodium hydroxide at the bottom. Little. Maybe at maybe at the top lot is there, at bottom little is there. So here reaction rate is high. Heat release will be high. Temperature will be high. Here reaction rate will be low. Heat released will be low. Temperature will be low. Now Buddha, I am putting the thermometer inside. If the thermometer is here, it will behave in a different way. If the thermometer is here, it will behave in a different way. If the thermometer is somewhere here, it will behave in a different way. Then can I get a constant final temperature? Can I get a constant final temperature? There will be different temperatures at different places of the solution, which means temperature won't be uniform. Now you all tell me, how to keep the temperature uniform? Everywhere temperature uniform. How to keep the temperature uniform? You stir it. So when you stir it, HCl and sodium hydroxide will distribute everywhere uniformly. When they distribute everywhere uniformly, temperature will be uniform throughout the mixture. Okay. So to maintain the temperature uniform, we stir. Write the answer there. Why should the solution be continuously stirred? Right there. To maintain the maintained temperature of the solution, temperature of the solution, uniform, uniform throughout the mixture, throughout the mixture, throughout the mixture. Again, I repeat, to maintain the temperature of the solution uniform throughout the mixture. Temperature of solution uniform throughout the mixture. Hurry. Next, there's a question. Just read the question. Just read it and don't go to even do it. Don't go to even think. Just read. Calculate the amount of heat released when 1 mole of HCl reacts with 1 mole of sodium hydroxide in the same above reaction. In the same above reaction. Onna question. Calculate the amount of heat released when 1 mole of HCl reacts with 1 mole of sodium hydroxide in the same above reaction. From nowhere, they are talking about mole. Until now, nicely the questions were going Q equals MC theta. You do the question, you find the answer. Now, suddenly from nowhere, mole is coming. Calculate the amount of heat release. They are asking the amount of heat release when 1 mole of HCl react with 1 mole of sodium hydroxide in the same above reaction. They are talking about same above reaction. In the same above reaction, when 1 mole of HCl, 1 mole of sodium hydroxide react, how much is the heat released? Hurry. How to solve this question? Listen very, very carefully. Eh? You miss a second, you'll have to forget about this section. Such a question, so listen very, very carefully. See, they are asking how much of heat released when 1 mole of HCl, 1 mole of sodium hydroxide react in the same above reaction. What is our same above reaction? What is our same above reaction? This one. This reaction. In that same above reaction, when 1 mole HCl, 1 mole sodium hydroxide react, how much of heat is released? Hurry. Leave that 1 mole story aside. First, we will find out in that same reaction, how much of mole of HCl reacted with how much of mole of sodium hydroxide. First, we will find that. Later, we'll go to that 1 mole story. Leave the 1 mole story aside. First, we will find out in the same above reaction, how many moles of HCl reacted with how many moles of sodium hydroxide. How many moles of HCl reacted with how many moles of sodium hydroxide. Now, this is the reaction. No? HCl aqueous reacting with sodium hydroxide aqueous. First, we'll write the reaction. Tell me, when HCl reacts with sodium hydroxide, what are the two products formed? HCl and sodium hydroxide, what are the two products formed? Sodium will join with chlorine. Sodium chloride, salts are soluble in water, aqueous, plus sodium went with chlorine. H plus will be released, OH minus will be released. H plus and OH minus. H plus and OH minus. 2 hydrogen, 1 oxygen. 2 hydrogen, 1 oxygen is H2O. H2O will be released in liquid state. That is our reaction. That is the reaction happening in that polystyrene cup. This is the reaction happening in the polystyrene cup. So we know the reaction. First, I will find the number of moles of HCl reacted and the number of moles of sodium hydroxide reacted. First, I will find out that. Right. Lamai, tell me, Is the equation balanced? Yes or no? Second time. Yes, equation is balanced. Hurry. First, I will find what's the number of moles of HCl reacted with number of moles of sodium hydroxide. How to find that? Is number of moles given? No. Some other details are given. Read the things needed part. 50 centimeter cube. What is 50 centimeter cube? Volume. 2 mole per decimeter cube. What is 2 mole per decimeter cube? Concentration of HCl. Volume is given, concentration is given. Volume is given, concentration is given. Volume of HCl, volume of HCl, volume of HCl 50 centimeter cube. Concentration of HCl 2 mole per decimeter cube. Even sodium hydroxide, volume is given 50 centimeter cube. Concentration is given 2 mole per decimeter cube. Unnalamai, volume is given, concentration is given. I don't know the number of moles. Is there any method to find number of moles using concentration and volume? What's the equation? What's the equation? Your mixtures lesson. Mixtures lesson. What's the equation? Concentration C is equal to number of moles N divided by volume V. C equal N over V. C value I know, V value I know. Can't I find N? We'll find it. I'll apply for HCl. I'll apply for HCl. For HCl. Concentration equal number of moles over volume. I need to find number of moles. I subject number of moles. If I subject number of moles, volume go to the other side. The number of moles is equal to CV. Number of moles N is equal to CV. Concentration I know. What's the concentration? 2 mole per decimeter cube. Concentration has come in decimeter cube. Then volume also should come in what? Decimeter cube. Tell me 50 centimeter cube. 50 centimeter cube. How many decimeter cube? 50 centimeter cube. How many decimeter cube? How many decimeter cube? How to convert centimeter cube to decimeter cube? How to convert centimeter cube to decimeter cube? Now these are mixtures lesson. Ne? How to convert? What you do? Memorize it like this. Still, if you are struggling, memorize it like this. Centimeter cube is like grams. Decimeter cube is like kilograms. Now tell me, using your scholarship knowledge, grade 5, grade 4 knowledge, how to convert grams to kilograms? How to convert grams to kilograms? Grade 4 knowledge, eh? Gram to kilogram. Divide by 1000. Same with centimeter cube to decimeter cube. Centimeter cube to decimeter cube, you divide by 1000. Enang opposite. Kilogram to gram, multiplied by 1000. Those things don't forget. Centimeter cube is like grams, decimeter cube is like kilograms, gram to kilogram you divide by 1000, kilogram to gram you multiply by 1000. So here 50 centimeter cube, tell me 50 centimeter cube, 50 grams, how many kilograms? 50 grams, how many kilograms? Divide by 1000. 0.05 kilograms. I thought a 0.05 decimeter cube. 0.05 decimeter cube. The decimeter cube, 0.05 decimeter cube. That's the decimeter cube value. So from there, I can find the number of moles. N is equal to 2 mole per decimeter cube multiplied by 0.05 decimeter cube. So when I do the math there, I will get 0.1 moles. Equation 1. So now I know the number of moles of HCl. Same way, we'll find the number of moles of sodium hydroxide. We'll find the number of moles of sodium hydroxide. Again, same equation, concentration equals number of moles over volume. Subject number of moles, N is equal to Cv. Concentration of sodium hydroxide is also 2 mole per decimeter cube multiplied by volume is 50. 50 you convert to decimeter cube, which is 0.05 decimeter cube. So if I do the math there, number of moles of sodium hydroxide is also 0.01 moles. Equation 2. 0.1 need 0.1 moles. So what is happening here? See, now look at the logic. Now it's the point where I'm going to apply the logic. See, 0.1 moles of HCl is reacting with 0.1 moles of sodium hydroxide. 0.1 mole HCl reacted with 0.1 mole sodium hydroxide. 0.1 are reacting. 0.1 are reacting. Look, now don't lose the concentration. 0.1 are reacting. 0.1 mole of HCl reacted with 0.1 mole of sodium hydroxide. You all tell me when 0.1 mole of HCl reacts with 0.1 mole of sodium hydroxide, how much of heat is released? When 0.1 mole of HCl reacts with 0.1 mole of sodium hydroxide, how much is the heat released? That is what we calculated. That is what we calculated. See, that is what we calculated in that box. For 0.1 mole HCl and 0.1 mole sodium hydroxide, how much is the heat released? That is what we did in this box. You didn't know that is 0.1 mole, but for that only you did the calculation. So in the calculation we got how much of heat? How much of heat we got in the calculation? In the calculation we got 4,200 joules. In the calculation we got 4,200 joules. That 4,200 joules is for what? That is for 0.1 HCl, 0.1 mole of HCl and 0.1 mole of sodium hydroxide. That is what reaction has taken place. For 0.1 mole of HCl and 0.1 mole of sodium hydroxide, 4,200 joules of heat is released. For 0.1 mole and 0.1 mole, for 0.1 mole and 0.1 mole, 4,200 joules of heat got released. Now come to the question. Now come to the question. What's the question asking? What's the question asking? Where? What's the question asking? Calculate the amount of heat released. How much is the heat released when 1 mole of HCl reacts with 1 mole of sodium hydroxide in the same above reaction? When 1 mole of HCl reacts with 1 mole of sodium hydroxide. When 1 mole reacts, how much is the heat released? When 0.1 mole react with 0.1 mole, 4,200 joules of heat is released. Question is asking, when 1 mole reacts, how much is it? How much? I don't know that. I'll just put the value Q. They're asking the Q value. Simple maths. In the maths, you get 5 bananas are 4,000 rupees. 5 bananas are 4,000 rupees. Then 500 bananas are how much? You all have a question? Supun goes to the supermarket and buys 10 mangoes for 2,000 rupees. Then 2,100 mangoes are how much? Same type. When 0.1 mole reacts, 4,200 joules of heat is released. When 1 mole reacts, how much? Now maths. Think like a banana question. Think like the mango question. 0.1 mango, 4,200. Then 1 mango, how much? Do. Now maths, eh? I think now, no kata no sina. Now maths. Understood the logic I have applied? Understood the logic? See, first the reaction is happening. They are given the concentration and the volume. Now, some people were wondering why concentration, why volume is given. Some people were wondering about it. This is why those things are given. So, concentration given, volume is given. So, from that, I can find number of moles. So, for this number of moles, 4,200 joules of heat is released. We already found it. For this number of moles, 4,200. Question is asking for 1 mole, how much? For this number of moles, 4,200. For 1 mole, how much? Find it. Work, work, work. You all do, you all do. Very good. All those who send the answers are correct. How to find it? This director maths question. If you have a maths question like this, how do you find it? How to solve this? Proportional questions. How to solve this? You divide. 0.1 mole, you divide by 1 mole. This side you divide. That will become equal to this side. 4,200 joules divide by Q. This side you divide, that become equal to that side. Now, I'm teaching the mathematical stepwise. Eh? Logically, you can do. Those who know the logic, they can do. I need to subject Q. If I subject Q, Q goes on top. Q is equal to 0.1 mole comes to the bottom. 4,200 will remain as it is. 0.1 mole comes on bottom. This 1 mole goes to the top. 1 mole goes to the top. Multiplied by 1 mole. Mole cancel off. 1, there is no this thing with 1. 4,200 divided by 0.1. 4,200 divided by 0.1. Jump a decimal. Here also you jump a decimal. So if you jump a decimal, you'll get another 1,000, another 10. You jump a decimal. Ekat also. You jump a decimal. Here also you jump a decimal. So if you jump a decimal, 4,200 become 42,000 joules. Now some people did it logically. 0.1 mole, 4,200 nang. 1 mole, how much? Look at the logic. If it is MCQ question, no need to do these things. 0.1 mole, 4,200 nang. 1 mole. What you're doing? What you're doing? This side you're multiplying by 10. Then this side also you multiply by what? You multiply by 10. Ehenang you all tell me. 10 mole. How much of heat will be released? 10 mole. Now you know 1 mole, 42,000. 10 mole. Type and send. 1 mole, 42,000. 10 mole. 420,000. 4 lakhs, 20,000. You can multiply and find. It's basically a ratio concept. Now I want you all to write this. How? Maybe these arrows I'll cancel off. Right? How to write it now? Everything should go there. Where? I'll show you all. First write this in that box. Write the top part in the box. Then the bottom part. This full box is for all the calculation I did now. Write this one first, then the bottom one. This first and the bottom one. Work. Quickly do, only few more section is there. We'll finish off the lesson. First write this. Okay, shall I go to the bottom? Yes. Now write this one. Done. Okay, no? Wait a minute. Okay. So don't we need to add both and get it 0.2? No, don't go to add it. Don't go to add it. Now, if you are calculating a certain mass, you can add it. Now here, Lamai, reaction is happening between HCl and sodium hydroxide. Now HCl and sodium hydroxide, not one product, no, one substance, no. Between HCl and sodium hydroxide, reaction is happening. That means 0.1 mole is reacting with 0.1. It's like a war. 0.1 mole is coming from HCl, zero point 0.1 mole is coming from sodium hydroxide. For that 0.1 only the war is taking place. Don't add it and make it 0.2. So it's a ratio. Keep the ratio as it is. You don't go to add and take 0.2 and find out the heat change. The war is for 0.1 mole, 0.1 mole. During that heat released is 4200. The war is not for 0.2. Okay. The ratio is 0.1 mole, 0.1 mole. For the ratio, 4200 joules of heat is released. If the ratio changes, the heat release will change. It's not the sum. The sum won't produce 4200 joules of heat. You don't consider the sum here. In the reaction, we don't talk about a sum. No. There's no sum in reaction. There's only ratio in a reaction. Okay, so you keep the ratio as it is and only find out the heat change. So according to the ratio, 0.1 mole, 0.1 mole is reactive. Not 0.2. You can't add because they are not one substance. They are two different substances. Right? So keep it as it is. Eh? I hope that's the only doubt you will get from there. Finally, a few more things. One. Now see. HCl aqueous reacting with sodium hydroxide aqueous. How much is the heat released? 4200 joules. Need HCl aqueous, sodium hydroxide aqueous, 4200 joules. I'll just do one change. Instead of keeping sodium hydroxide aqueous, I'm going to put sodium hydroxide solid. Can put no? Directly I put some sodium hydroxide solid. Will the heat release be 4200? The answer is no. It won't. It won't be 4200. Guaranteed the heat change will change. For aqueous hydrochloric acid and aqueous sodium hydroxide, 0.1 mole, 0.1 mole, 4200 joules is released. In case if you change it, aqueous hydrochloric acid with solid sodium hydroxide, 0.1 mole, 0.1 mole, heat change will change. So which means, tell me, heat change depends on the state or doesn't depend on the state? It depends. Heat change depends on the state. If you change the state, guaranteed the heat change will change. That's why I told you in this lesson, it's a must to write the states. Can you remember day one session I told? It's a must to write the state because heat change depends on the state. So that point is given to you. Special point. Heat change happening during a chemical reaction depends on the physical state of the reactants. Underline or highlight that. Depends on the physical states of the reactants and the products. Therefore, it is a must to indicate the physical states. It's a must. Finally, now you will ask me, sir, how to find the exothermic reaction, how to find the endothermic reaction. I'll give a list of exothermic and a list of endothermic reactions in our syllabus. I'll give a list, so with that you can find it. Now you all are going to work with me. You all are going to tell me. Tell me neutralization, exo the endo the. Exo the endo the. Everyone knows neutralization exo. Neutralization is exo. Combustion, burning petrol, releases heat or absorbs heat. Exo, endo. Exo. You burn petrol, lot of heat is released. You burn diesel, lot of heat is released. You burn a paper, heat is released. So combustion, exo, endo. Exo. Combustion is exo. Combustion is exo. What about photosynthesis? Now, when I tell exothermic, endothermic, don't only think in terms of heat change. Heat is an energy. It can be any energy absorbed, any energy released. Any energy absorbed, any energy released. Photosynthesis. Light energy is absorbed. Endo the exo. Endo. Photosynthesis, endo. If photosynthesis is endo, what about respiration? During respiration, our cells produce energy. It gives out energy. During respiration, energy is released. Endo the exo. Exo. During respiration, energy is released. Exo. Me, what am I writing? Respiration. Exo. What about decomposition reaction? Decomposition. Can you remember decomposition? Hmm? Decomposition. Calcium carbonate decomposition. When calcium carbonate decomposes, calcium oxide and carbon dioxide are released. This is solid, this is solid, this is solid. What does this heat symbol symbolizes? What does this heat symbolizes? What does the triangle symbolize? I gave the answer. What does the triangle symbolizes? Heat, need. It symbolizes heat, heating. So calcium carbonate is heated. You are supplying heat, which means calcium carbonate is absorbing heat. Calcium carbonate is absorbing the heat and becoming calcium oxide and carbon dioxide. Absorbing heat. Now tell me, endo the exo. Endo. Remember, decomposition is endo. Decomposition, endo. If I give an example, calcium carbonate solid decomposed to form calcium oxide solid. Plus carbon dioxide gas. Endo. Decomposition. Uh, I'll give another exothermic. Exothermic. Now, to produce slaked lime, quicklime will be dissolved in water. Quicklime is dissolved in water. Quicklime is calcium oxide. Calcium oxide, when you dissolve in water, what you get is calcium hydroxide. What you get is calcium hydroxide. This is a exothermic reaction. So we can write dissolution of quicklime. Dissolution of quicklime, it is exothermic. Write this exothermic and endothermic reactions. Okay. Done. Done, sir. Okay, sir. No, sir. Okay. Okay, no. So that finishes our eighth lesson. Fully done, ne? Fully done, eighth lesson. Day one session, day two session, both together, eighth lesson with calculations are done. What I need from your end is again take the questions, the 10 questions there, try to redo the questions once more in case, especially if you are wrong at any questions, try to redo it. Maybe calculation errors, maybe zeros, maybe some sort of even small mistakes may be there. So try to redo those questions, right? So that's the thing. So with that, our eighth lesson is done. I hope there are no any doubts. Okay, no? No doubts. Everything clear. In case if there's anyone new watching this, please watch your day one session as well. It's also there in the YouTube. So go to the YouTube. Please subscribe to the channel. Put a like there, right? And then watch that video. Then you can watch this series. It's the second video. Alright, those are the things I wanted to tell. Ehinang, I'll meet you all again with another session. Until then, keep working.